Yes, good afternoon everyone. So yesterday we completed the amino acids and how these amino acids are going to have the properties. And now we are going to discuss proteins. What are proteins? Proteins are nothing but we can say the polymers of amino acids. Already we discussed L amino acids are going to be the building blocks for the protein. So amino acid is going to be combined with one more amino acid to give your protein. Now we are going to have the bond between the two carbohydrates, what we call glycosidic bond. Similarly, the two amino acids are going to form a bond called peptide bond. That's why a protein can also be considered as polypeptide because it's going to have many number of peptide bonds. That's why you can call that one as polypeptide. But we are having a little bit confusion regarding the number of amino acids which are present in a particular one is going to decide whether it is a peptide, polypeptide or a protein. So here we will get that clarity. Before going to that one, we are going to discuss now how a bond is going to be formed between the two amino acids. What is that bond called? Peptide bond. This is what amino acid we are going to have. Now, one more amino acids I will take like this. Now, the hydrogen from one amino group and OH from your carboxyl group will be going out as water molecule and they are going to form a bond called peptide bond. The peptide bond is nothing but it's an amide bond. So the bond which is present here is called as peptide bond. This is the one we are going to call it as peptide bond. What is the peptide bond? The bond present between the two amino acids is called as peptide bond. This is one alpha amino acid. This is one alpha amino acid. The two alpha amino acids are combined by the losing of water molecule, which is going to be called the bond formed is peptide bond. And now this peptide bond is having one COOH free and one with NH2 free. We are going to call this one as N terminal and this is going to be called as C terminal. The N terminal to C terminal we are going to give the amino acid sequence so that indicates N end or N terminal is going to have a free amino group and C terminal or a C end is going to have carboxyl group is free. That is what you can say, the N terminal to C terminal. That is what we are going to have and this bond is called peptide bond and this peptide bond is going to be very rigid. Usually you are going to have amide bond. This is only amide bond. We are going to call this one as also chemically amide bond. This is going to be existing in trans configuration. This is going to give huge stability for that molecule. It is not going to be hydrolyzed easily by water. Normally, whenever you are going to take any water condensation product, say ester is going to be formed by RCOOH plus ROH is going to give water molecule out and we are going to get ester. That is going to be when ester is added up with water, that is going to give you the alcohol and acid back. But here it is not that much easy. When we are going to add the water to this peptide, it is not going to hydrolyze easily. It is not going to give easily the amino acid. Why this is going to get that much stability? The first one we can say the stability for this one because of it's existing in trans configuration. This is going to be existing in trans configuration. Trans is almost stable than cis configuration and it is going to existing in a resonance. So here we can say the CO minus and N is going to give to this one so that we can able to get the resonance structure like Like this, it can show resonance. So because of resonance also, it is going to have stability. So because of resonance, because of trans configuration, your peptide bond is so rigid, that's why it is not going to be hydrolyzed easily. So one more amino acid if you want to add, here I am going to get one more amino acid, so that we are going to get one more peptide bond. And the formed one is going to be called as dipeptide. It is called as dipeptide. So everyone is having a thing like, when we are going to take dipeptide, we are thinking like it's going to have two peptide bonds. It's not the peptide bond. Always the peptide is going to be representing the number of amino acids. Number of amino acids we are going to have. So dipeptide is going to have two amino acids and one peptide bond. We can remember the number of amino acids are representing this di, tri, tetra. So decapeptide is going to have how many amino acids? Deca means 10, it is going to have 10 amino acids. And how many peptide bonds we are going to have in this? We are going to have number of amino acids minus 1 will be the peptide bond. 10 amino acids are there, 10 minus 1, we are going to have 9 peptide bonds. So that's why just remember every time whenever they are asking how many peptide bonds will be there in a given compound. Like tripeptide will have 3 amino acids, 3 minus 1, 2 peptide bonds. Tetrapeptide will have 4 amino acids and minus 1, 3 peptide bonds. Similarly, like that we are going to have decapeptide. Decapeptide will have 10 amino acids, minus 1 will be the number of peptide bonds, 9 peptide bonds. This is how we are going to have the peptide bonds are going to be calculated depending upon the number of amino acids minus 1. That will be their peptide bonds. And if you can take an example of tripeptide or decapeptide, always we are going to represent like N terminal to C terminal. What that mean? N terminal is going to have free amino group. Somewhere it is going to have free amino group, that is called N terminal, and this is having free carboxyl group, it's called as C terminal. Middle I am going to have many peptide bonds. So that is what we are going to represent the position of N terminal to C terminal. Understand? And now we are going to discuss about the oligopeptide, polypeptide proteins. When we are going to have 2 to 20 amino acids, we are going to call that one as oligopeptide. 20 amino acids are there, it is going to be called as oligopeptide. And when we are going to have 20 to 100, I can consider this one as polypeptide. More than this one is going to be called as protein. It is not a as it is situation we are going to follow. Just for easy understanding purpose I am saying this one. 2 to 20 amino acids are present, then it is going to be called as oligopeptide. When we are going to have 20 to 100, we are going to call it as polypeptide. Greater than 100 amino acids, we are going to call it as protein. This is what I am saying it. But insulin is going to be a hormone which is going to have 51 amino acids. We are not calling that one as polypeptide. That is going to be considered as protein only because of the structure what it is going to have. It is made up of A chain and B chain. They are going to be having the linkage with the sulfurs. So when we are going to have a complicated structure, then also we can able to call that compound as protein. But even the later less than 100 amino acids are there. Just for a instance I am saying this one, but so many number of proteins which are having less than 100 amino acids are also going to be present. Depending upon their structure, we are going to consider them as proteinaceous. Understand? So this is about the peptide bond and oligopolyproteins, how we are going to name them. Say for example, if I want to calculate the number of peptides are going to be formed by a protein, number of amino acids, what I can able to write? Suppose I am having a number of amino acids, I am going to get these many number of peptides are possible. Say for example, if it is a dipeptides, if they are asking, they are going to be M is equal If you are writing for a tripeptide, M is equal to 3. If it is tetrapeptide, M is equal to 4. So, the number of amino acids, say for example, with 2 amino acids, how many dipeptides I am going to write? So that we are able to write the dipeptide, this is going to be 2 amino acids, will always form only one type of dipeptide. So then we are going to have more number of amino acids are there. Then how many dipeptides are possible with that one? Then we can able to take 3 power. How many dipeptides means 3 square. So what we are going to get 9 dipeptides are possible. 9 dipeptides are possible. We can able to write it. Understand? So 2 amino acids are there. 2 power 2 we are going to have 4 dipeptides are possible. So A, B and B and BA. So the arrangement N terminal to C terminal is going to be changing. AA you can write, BB you can write, AB, BA. So that is how we can able to write the 4 peptides, dipeptides by using 2 amino acids. 3 peptides, so 3 amino acids, you have to write dipeptides, 3 power 2, it is going to be 9. Just you can able to try how many are going to be present. So that is how we can calculate the number of peptides formed by a particular amino acids number they given, and they are given tetrapeptide or bipeptide like that. We can able to calculate like this. They have asked already this question sometimes. Just you have to remember A power M. A is number of amino acids. M is what peptide they are asking. Whether they are asking dipeptide, tripeptide, tetrapeptide, that is going to decide this M value. For dipeptide it is M is 2. For tripeptide it is 3. Tetrapeptide is 4. That is how we can able to write the number of peptides possible by a given number of amino acids. Understand? So it is very easy. We can able to write this particular number of peptides formed by a given number of amino acids. Fine. Next one, structural organization of protein. When we are going to take your protein, it is going to have primary structure, secondary structure, tertiary structure, quaternary structure. If you are taking your protein, it can able to show 4 structures: primary, secondary, tertiary, quaternary. So what the primary structure is going to explain, that is what we are going to study here. It is a structural organization. This primary structure is going to explain about the sequence. What it is going to explain? Sequence of amino acid. What is the meaning of sequence? The number 1 which is going to be present, number 2 what is going to be present, number 3 what is going to be present. Say for example I am having 100 amino acid containing peptide. In that one position is going to be having which one? 90th position which is present and 100th position which is present. That can be explained by sequence, that is explained by primary structure. So what is the meaning of sequence? The position of the amino acid present in a given protein was explained by your primary structure. How we can able to get this primary structure? It is because of stabilization peptide bond. Already what we discussed, that is only going to stabilize. Primary structure of protein is going to be stabilized by peptide bond. It is going to explain about sequence. How it is going to explain sequence? Say for example, I am having CH, NH2, CO, NH, CH, CO, so like that if you are taking we are going to have the so many number of amino acids can be present in a given compound. See this one. So it's a first amino acid. It is going to have R group, and here also I am having one R group might be present. Here also I am having one R group. That R can be anything, whatever it is. So now I can say N terminal to C terminal. I am going to say for example, here I am having glycine, alanine and methionine. Like that I am going to have so many number of amino acids. So it can be able to explain by your primary structure because it is stabilized by your peptide bond. Peptide is going to stabilize this particular primary structure. It is going to be explaining about the sequence of amino acid. Understand? So the primary structure is nothing but it's a sequence of amino acids can be explained, and one position we are going to have, second position what you are going to have, third position what you are going to have, all those things can be explained by your primary structure of protein. In this primary structure of protein, the stabilization of primary structure is going to be done by your peptide bonds which are present. The backbone for your primary structure is going to be peptide bond only. Now coming to the secondary structure. Secondary structure is going to give the shape. Say for example, primary structure is not able to explain what shape they are going to have. Proteins are going to have different shapes. How these proteins are going to be getting different shape. Each amino acid is very important for the shape of that particular one, which is evident by your sickle cell anemia. Hemoglobin is going to have so many number of amino acid. Out of them, one amino acid, valine and glutamic acid are going to be exchanged, so that we are going to get the shape of your hemoglobin is changing. So that is, it is very important like what amino acid composition we are going to have in a given protein. It's very important for its properties as well as structure. So now this is not going to explain any shape of this particular protein. The shape and all are going to be explained by your secondary structure. It is going to explain shape, what we are having for a protein going to be explained by this one, and it is going to be stabilized by hydrogen bond. It's going to be stabilized by hydrogen bond. Even sometimes you can have disulfide bridges. We can have disulfide bridges. How many we are going to have the hydrogen bond? How it is going to be possible? First of all, what is hydrogen bond? What is hydrogen bond? What is hydrogen bond? Whenever the hydrogen is going to be present along with high electronegative element F, oxygen O and nitrogen N. Fluorine F, oxygen O and nitrogen N, FON, fun. So when these three are going to be present along with hydrogen, that hydrogen can able to create the interactive forces between two molecules, because that hydrogen is going to be bridging between the two molecules. For example, HF, one HF molecule, another HF molecule will have extra interactive force due to this hydrogen. That's what is called as hydrogen bond. H2O, NH3, all of them are going to have hydrogen bonding among them. Because of that reason, they are going to be getting a more stability. Here also we are having O is there, H is there. We are having O and H. So already they are having the bond between them. So they are existing in regenerating structure. Now one amino acid CO or NH can able to form a hydrogen bond with one more oxygen or this nitrogen. As they are in trans configuration, whenever they are going to form hydrogen bond, they are going to get so like this, they can able to bend. So as they are having hydrogen bond here, here, here. So they are having hydrogen bond. Because of that one, they are going to be get spiral nature. It can be right-handed or left-handed. This particular structure is called as alpha helix. This helical structure is called as alpha helix, which is formed due to the hydrogen bond between one peptide bond to another peptide bond. Usually we can expect some 3.6 amino acid in each helical. It is not exact, it will be approximate. 3.6 amino acids, we are going to get one hydrogen bond possibility is there. That is what you can able to see from this alpha helical. Alpha helical can be right-handed helix or left-handed helix. Anything can be the present in helical structure. Understand? So this is about alpha helix. We are having one more secondary structure which is going to be called as beta pleated sheet. Which is going to be called as beta pleated sheet. This beta pleated sheet is going to be present between two polypeptide chains. Say for example, I am having it can be one polypeptide chain only we can able to get, then we can call that one as hairpin bent. But otherwise you can able to get between two polypeptide chains. So there is a chance of getting hydrogen bond like this. So this hydrogen bond is making a sheet, pleated sheet appearance. That's why we are going to call this one as beta pleated sheet. So the primary structure of protein is going to be get folded and we are going to get helices or we are going to get pleated sheets so that we can able to get developing of secondary structure. Secondary structure is going to be stabilized by hydrogen bond or even disulfide bonds. We can have disulfide bonds. Coming to the tertiary structure of protein. Tertiary structure of protein is nothing but further folding. Already they are getting folded. Now further folding of this secondary structure is resulting in the formation of a still compacted structure which we are going to call that one as tertiary structure. This tertiary structure is going to be explaining biological activity of that protein. This is going to explain biological activity of protein. The folding of a protein is going to be giving that a particular biological activity. That biological activity of a protein is going to be determined here because of tertiary structure only. The proteins are going to have so many functions. They have structural function. They are having some biological activities. Whether it has to acting as a skeletal or whether it is acting as muscular, whether it is going to acting as an enzyme, whether it is going to act as hormone, that all the things are going to be decided by your tertiary structure. That tertiary structure is stabilized by so many forces, that peptide bond, all these forces anyway they are present. Other than this one, we are going to have hydrophobic, hydrophilic, we can have van der Waals force, like that. So many forces which are going to be present, ionic forces will be present. So all these are going to be stabilizing your tertiary structure. So the tertiary structure is going to be getting folded. They are going to develop a domain, we are going to call that domain is going to decide whether it will act as enzyme or hormone or a structural protein. All these things can be explained by your tertiary structure of protein. The tertiary structure of protein is nothing but responsible for the biological activity. Understand? So this is going to be tertiary structure. How we are going to have, say for example, this is further folded, we can have like this structure. So this is nothing but your tertiary structure. That folding, further folding is going to result in the formation of a structure called tertiary structure. Now we can have quaternary structure. This is nothing but formation of two tertiary structures are going to be get combined. Say for example, hemoglobin is going to be formed by 4 chains, that is 2 alpha, 2 beta 2 or A to B2 we are going to call them as. So that is nothing but quaternary structure. So this is how we can able to, if you want to remember your structure of protein, the primary structure is nothing but when we are going to have earlier landforms. Earlier landforms is having one connection wire between your base of the phone and the receiver of the phone, that hand what we are going to call. So with that we are going to have one spiral ring connection. So that spiral ring, if you are extending, that is going to be primary structure of protein. That is going to be linear. When you are leaving it, it can become to secondary structure. Introduce still more coiling if you are doing it, it is going to be tertiary structure. Take such two things and you join them, that's quaternary structure. Simple words, if you want to say, the telephone wire example, you can remember it. That is going to be, we will be explaining your primary, secondary, tertiary, quaternary structures. Is it clear for everyone? The primary structure, secondary structure, tertiary structure. The important one they are asking is, which one is responsible for the biological activity? Tertiary structure. How tertiary structure is stabilized? It is going to be stabilized by electrostatic forces, hydrophobic forces, hydrophilic forces, and van der Waals forces are going to be present. And how secondary structure is going to be? Alpha helix and beta pleated sheets. How they are getting stabilized by? It is because of hydrogen bond and disulfide bond. And the primary structure is stabilized by peptide bond. That is what we are going to have. Here only I will introduce one term called denaturation. I will introducing now denaturation. D means removing. Naturation means naturality is removed. How the naturality is going to be removed? So it is nothing but a loss of biological activity by a physical or chemical change is called as denaturation. What is denaturation? The loss of biological activity by a protein due to a physical or chemical change. If you are changing the pH, if you are changing the temperature, then we are going to lose the activity of protein, then it is going to be called as denaturation. During the denaturation, the usually question what you are going to get is, during denaturation, which of the following structure is not going to be get disturbed? Why the denaturation takes place? It is going to straight away disturb your tertiary structure. That bonds what you are having going to be broken, so that it is losing its activity, and then when they are going to have primary structure, it is going to be not disturbed by any mean. Not disturbed by any mean. It is going to be remain same as it is. Why it is? I already explained. That is the stability of peptide bond as it is existing in trans configuration and showing the resonance. That peptide bond will not be get hydrolyzed by a temperature change or a pH change. It remains same. That's why if they are asking the question which is not going to be disturbed, primary structure of protein is not going to be disturbed by your denaturation. Which is going to be disturbed readily? Tertiary. Further secondary. But primary is not going to be get disturbed. That we are supposed to be remember. Understand? This is about structural organization of protein. So that's about the structure of protein. Now we'll see the classification of protein. Now the classification of protein, if you're taking, the classification can be based on composition. First one, based on composition we can give. So based on composition, you can have simple, conjugated, derivative or derived. We can have three types of proteins are going to be present: simple proteins and derived proteins and conjugated proteins. So when we are going to take simple proteins, they are made up of only amino acids. When we are going to have only amino acids present in a given protein, then they are called as simple proteins. Conjugative proteins, along with amino acids, we are going to have some conjugate part. Some conjugate will be present along with this one. When we are going to have derived, they are going to be derived from either simple proteins or conjugated proteins. Understand? Composition. Only amino acids are present, or we are going to have along with amino acid one more extra part like carbohydrate or nucleic acid or some metal is going to be present. Then they are called as conjugative proteins. When we are going to derived proteins means they are going to be derived from either simple amino acids or conjugate. Simple proteins, the naturally all what we can see usual proteins are comes under simple amino acids only. The simple amino acid containing ones are going to be called as simple proteins. Now we are taking egg albumin or globulins. All these proteins are going to have only the amino acids. They are not going to be present anything other than amino acid. That's why they are called as simple proteins. That simple proteins are going to be, example if you can take, it's globulin, albumin, insulin, all these proteins, whatever we know that generally, they are all comes under simple proteins. Now coming to the conjugate proteins. These conjugate proteins are going to be again divided into glycoproteins, nucleoproteins, lipoproteins, chromoproteins, so when we are going to take the conjugative proteins, there are going to be several types based on what they are going to be present. Even you can write phosphoproteins also. So these are all having, other than amino acid, some other part is there. Glyco means carbohydrate. We are going to have protein along with a carbohydrate, that's called as glycoprotein. If you are having phosphoproteins, usually you are going to have so many phosphoproteins are present in our body which are going to be helpful for so many ways. So that is going to have phosphorus along with your amino acid. They are going to be phosphoproteins. Main one we are going to take the milk protein, casein is going to be present along with the phosphorus. And nucleoprotein, that is histone proteins are going to be present along with nucleic acid. The nucleic acid part is present along with the amino acid. We are going to call them as nucleoproteins. We are going to have lipoproteins. They are going to be a part of cell membrane. That cell membrane is going to have the lot of bioenergy is going to be because of lipids what they are going to be present, that lipoproteins. And we are going to have chromoprotein. Say for example hemoglobin, it is going to have some prosthetic what, that is heme is going to be present with your protein globin part. That's why it is called chromoproteins. So these are all examples for the conjugate proteins. When we are going to derived proteins, when we are going to have proteins are going to be get digested, they are going to give proteoses, peptones. These are all comes under derived proteins. So now the classification of this protein is going to be based on the composition of the protein. Simple protein, conjugate protein, derived protein. The simple protein is nothing but it's made up of the amino acids only. We are not going to have any other thing than amino acid. The examples are globulin, albumin and insulin. These are all comes under. And conjugative proteins. These conjugate proteins are going to have, other than amino acid, some extra part like a carbohydrate or phosphorus or non-metal, metal, nucleus. All these things are going to be present. They are called as conjugative proteins. And we are going to have derived protein. They are going to be derivative of either simple protein or conjugate protein. That is proteones, peptones. These are all comes under your derived proteins. This is one way of classification of protein we are going to have. And second classification is going to be based on their shape. So based on shape, if you want to divide, we are able to get two types: fibrous, globular. We are going to have two types of proteins will be there present based on shape. Now we are going to take fibrous, globular. The fibrous means which is going to be fiber-like. When we are going to get fiber-like, they are all comes under linear proteins which are present like ribbon-like. They are going to be present ribbon-like, one another to parallel. parallelly one another is going to be arranged. It's called as ribbon-like arrangement. They are going to be acting like fibers. That's why we are going to call them as fibrous proteins. They are all linear and they are going to be fibrous. As they are having flat ribbon-like shape, they are called as fibrous proteins and they are going to get spherical. Why they are spherical? When we are going to have so many foldings for a given protein, they can able to obtain a spherical shape. So that spherical shape is going to be giving a globular, that's why we are going to call them as globular proteins. And here it is going to be linear because it's a flat ribbon-like structures, that's why they are going to be having fiber-like structure, that's why we are going to call them as fibrous proteins. And next one, this is going to be water insoluble. This is going to be water insoluble and this is going to be soluble. Globular proteins are water soluble and fibrous proteins are insoluble. And the bonding we are taking, here we are going to have less bonding, here we can have more bonding. And because of this, most of the proteins what you are having, the enzymes and all comes under globular and the fibrous proteins are going to be skeletal or muscular. So the examples we can take, we can able to write myosin, muscular protein, and skeletal protein collagen, fibrin, all these things are comes under fibrous proteins. And coming to the globular proteins, example insulin, glucagon, albumin, all these things are comes under your globular proteins. So the proteins are going to be having the classifications, two types of classification. One classification is based on the composition, simple, conjugate and derived proteins. When we are going to take the based on shape, we are going to have two types, fibrous and globular. Fibrous proteins are the proteins which are going to have the parallel arrangement of polypeptides so that we are going to have ribbon-like shape. That's why they are going to be called as fibrous proteins. Whereas the globular proteins are going to be having further folding and folding and folding and they are going to attain the spherical shape so that we are going to call them as globular proteins. And when we are taking the fibrous protein, they are insoluble in water and globular, they are going to be soluble in water. And examples, if you are taking all your skeletal proteins, muscular proteins are comes under fibrous as they are going to give strength for your body. That's why the examples are myosin, troponin, tropomyosin, collagen, all these things are comes under fibrous proteins. Whereas globular proteins are going to be insulin, glucagon, albumin, all these things are going to be comes under the globular proteins. So this is what the classification of proteins we are going to have. And what we discussed for amino acid, the same thing will be there for your proteins also. So what we discussed, isoelectric point. What is isoelectric point? Isoelectric point is nothing but the pH at which the amino acid existing in deuterionic state. As you are having the composition of protein is made up of amino acids only, that's why they also will be existing in deuterionic form. That's why they are the responsible for isoelectric point is going to be present for even protein also. And denaturation already we discussed. And coming to the functions of your protein, we can have so many number, n number of functions will be there for your protein. Say for example, they can be acting as hormone, they can be acting as an enzyme, they can be acting as structural proteins, they can be acting as your membranal proteins. So many functions will be there. Hemoglobin, oxygen transporter, that is also a protein. So without a protein, we are not going to have anything that we can say. The proteins are going to be very important part of our body and they are going to be playing a lot of roles, metabolic roles and structural roles are formed by your protein. And next, if you are going to take the protein tests, how we can able to identify these proteins, we can see now. So we are going to have the first identification test for protein is biuret test. The biuret test is going to be we are adding copper sulfate. The copper sulfate, when it is added to the protein, that is going to be developing the blue color. So that is nothing but the presence of peptide bond. The Biuret test is going to be given even by amide linkage. Whenever having urea also will give. So this, wherever that CO and H bond is there, that is going to give a Biuret test. And already ninhydrin test we discussed for amino acid. So the ninhydrin is also going to give a test for your protein also. They are developing the purple color whenever the protein is going to be combined with your ninhydrin. And xanthoprotic test. Xanthoprotic test is very common one. Whenever you are going to touch HNO3, nitric acid, that is going to develop yellow color on your skin. Why it is? Whenever a protein is going to be formed by an aromatic amino acid, that aromatic amino acid obviously is going to be reacting with your nitric acid, that is developing yellow color. If you are adding NaOH to that one, it is developing into red color, deep red color. So that is nothing but a protein presence only indicated by your xanthoprotic test also. And moreover, we are supposed to discuss here regarding the denaturation. So what is denaturation? We said physical change or chemical change is going to lead the loss of biological activity. So then renaturation, if you are going to cool or if you are going to change the condition, again there is a chance of getting reback. Certain cases, it is not always possible. We are going to get certain cases, the renaturation is also possible. And a best example for this denaturation is your coagulation of egg. When we are taking an egg, raw egg, it is going to be present in liquid state. That liquid state is going to be converting into your solid white. That is nothing but your denaturation of protein. So my question, and is an NCERT question, when we are going to take your egg that is going to be present in a liquid state, that is going to be converting into solid state, where that water or liquid is going to be gone. So when we are going to make that shell, we are not going to find any water inside, just it is only a solid state. So that is the question they given in NCERT, where it went. The answer for this one is, the water is enter or the liquid is enter into where the denaturation takes place. There we can have the spaces, that spaces are occupied by that liquid. That is what we can able to say. Wherever the denaturation takes place, the breaking of bonds takes place. Wherever the bonds broken, there the liquid is entering, so that we can able to make that water or liquid disappear when we are going to do the boiling of egg. So that is also one time they are asking the question, just remember it. This is about your proteins part. Next we will see what are the important proteins we are having. Enzymes. What are enzymes? They are nothing but proteins only. All enzymes are proteins, but all proteins are not enzymes. Isn't it? We can have all enzymes are proteinaceous in nature, but except one exception is there, that is spliceosome complex RNAs, that is nothing but RNA only, but it's not having any protein. But all enzymes are proteins except that RNAs, and these enzymes are nothing but biocatalysts. This enzyme name for biocatalyst is given by Frederick Wilhelm Kuhne. It's not that much important, the scientist name. The biocatalysts are enzymes. So what do you mean by biocatalyst? Catalyst means which is going to increase the rate of reaction without changing on its own. It is not undergoing any change, but it is going to make the rate of reaction to be increasing. That is called as enzyme. Here the enzymes are biocatalysts. That means they will be operating biochemical reactions. Normal catalyst is going to operate chemical reaction. Your enzyme is a biocatalyst which is going to operate your biochemical reaction. That is going to be called as biocatalyst. It's going to be called as biocatalyst. Okay, so what are the important characteristics about enzymes we are going to study in surface chemistry, and we will be discussing the examples of enzymes also in surface chemistry. Okay, just a brief introduction for enzyme I am going to give. Enzyme is going to react with your substrate. It is going to form ES complex, enzyme substrate complex, and enzyme substrate complex is going to give free enzyme and product. This is what we are going to have. The reaction when the enzyme is going to be involving, enzyme plus substrate gives rise to enzyme substrate complex, which gives rise to free enzyme plus product. Free enzyme plus product. When we are going to have this enzyme and substrate, we are going to explain the mechanism based on lock and key model. We are going to have lock and key model. Suppose your enzyme is like this. This is going to be called as active site. This is going to be called as active site. The active site is the site which can able to be having specificities towards a substrate. Say for example, I am going to have like this, so many substrates are there, but this is the substrate can able to be fit into this active site, so that only this one can able to make a bond here. That is how we are going to get enzyme substrate complex. Now this is going to act on this one, and then your enzyme is coming back, and the substrate can be divided into two products, like it is dissociated. Understand? This is now the enzyme, how it is going to be acting. It is an enzyme which is going to have a specific site to bind a substrate. That specific site to bind a substrate is called as active site. That active site is designed for, as they said, no, that one, biological activity of a protein is going to be determined by your tertiary structure. What the tertiary structure is going to do, I am showing like this. Don't think that enzyme is going to have like in this a bowl we are going to be. It is not going to be like that. It is going to be having a certain shape. For that shape, our substrate is going to be get fitted. It is going to be get fitted. So here what is going to be happen? A substrate, when it is going to be coming, that is going to be get binded by your enzyme. How this is going to get this domain? The folding and folding and folding, we are going to get a tertiary structure domains. I said the domains are having a certain groups are going to be protruded. That groups can able to form a binding for this one. Say for example, if anything is like actively having like this, and that active ones will come, immediately they are going to form a bond. That is how that active site is going to be designed in such a way that it is going to be protruding some functional groups. That functional groups are going to readily form the bonds with your substrate, so that we are able to get this enzyme substrate complex formation. This is highly energetic, immediately having the action of enzyme on the substrate. Say for example, this enzyme I am taking maltose. This is maltose, this is enzyme maltase. What is the action of maltase? Maltase is going to dissociate the maltose into 2 glucose. That is what I have shown here. This can be divided into 2 parts, that is 1 glucose and maltase enzyme coming back. That is how I am explaining here the enzyme action. What are the different names of enzymes we are having? Maltase, it is going to be acting on maltose. Lactase, it's acting on lactose. Sucrase or invertase is going to be acting on sucrose. So like that we are having the enzyme names always is going to be like ase is going to be, and amylase is acting on amylose. And we are going to have the certain enzymes like pepsin is going to be acting on protein. Trypsin is going to be acting on protein. So all these are going to be examples for protein enzymes. We are going to have urease acting on urea. Okay, ammonia synthetase or lactobacillus is an example for which is converting your milk into curd. That is also going to be producing an enzyme. So like this we are going to have so many enzymes named. Gymase, glucose to ethanol. So you can go through those examples what you are having in NCERT. Actually, that is going to be there in surface chemistry, mostly we are discussing. So there we can able to have all the list of enzymes. Here, this much is enough for me to have an enzyme minimum idea which is going to be formed by a protein. Is it clear? So the next one we are going to discuss is vitamins. Earlier the vitamins are going to be called as vitamins. They are called as vitamins. That means the amines which are going to be playing a vital role in a biological all functions are going to be called as vitamins. Later it is going to be coming as vitamins. Anyway, you are going to study these vitamins in your biology more. Just I am going to be discussing here the chemical name and their deficiency. Deficiency also you are going to learn there. Just I am going to give brief. And moreover, I am specifying one thing here. Just the sources what you are going to have for vitamins, you have to by heart from NCERT textbook. I am not able to copy the NCERT table here. Just I am going to explain a few things about the vitamins, but you people supposed to be by hearting from your NCERT. If they given milk or fish is an example for. So if NCERT they given for D vitamin, so you have to mention D vitamin only. No other option for us. So we can't able to argue with the person who preparing the question paper, because if it is given in NCERT, that's why follow the sources what we are having, follow NCERT table what we are having. So the same thing is only better for final NEET exam also. Just I am going to here give the chemical names for a given vitamins. The vitamins are broadly divided into two types. What they are? Based on their solubility. We are going to have two types of vitamins. They are fat soluble water soluble. Fat soluble vitamins and water soluble vitamins. A, D, E, K. These four vitamins are going to be called as fat soluble, as they are going to be dissolving in fats or cholesterol or lipids. That's why they are called as fat soluble vitamin. And when you are going to come B complex and C. So B complex and C vitamin are comes under water soluble. They are dissolving in water. I think regarding the vitamins, everyone is going to be get a clarity and more knowledge nowadays because of corona. So the corona is going to be specifically affecting the metabolism of vitamins only. Wherever the vitamin is important, there only it is going to make the interruption, so that it is causing a heavy damage for the body. So that is why everyone is taking now Zincovit or vitamin D capsules. Like that we are going to take a lot of vitamins. So that's why knowing or knowledge of vitamins is very important for us. So already you are having idea in your biology, as we have to specify here the vitamins is there in chemistry, we are taking the explanation here, but you are supposed to read symptoms and sources from your biology part. Just I am going to give here chemical names only. Understand? Vitamin A, this is called as retinol. Chemically it is called as retinol or hydroxycisretinol we are going to have, and deficiency of this one is going to cause xerophthalmia. We are going to get xerophthalmia, or you can say night blindness. This is what we are going to have the symptoms, what we are going to get from the deficiency of retinol is xerophthalmia, night blindness, and even it will cause hypervitaminosis. When we are going to take that A in excess, we are going to get hair fall. that is usually you are going to take from the vitamin A. And coming to vitamin D, it is going to be called as vitamin D2 is there, vitamin D3 is there. What vitamin D3 you are having is called cholecalciferol, which is called as chemically cholecalciferol. D2 is called as ergocalciferol. These are the chemical compositions we are having for the vitamin D, and they are going to cause rickets in children, osteomalacia in adults. Both of them are going to have same, but we are going to have a weakening of bones in case of adults, that is deposition of calcium is going to be not taking place. So that is going to be called as osteomalacia. Rickets is weakening of bone, that is tenderness, that is going to be happen for children. That is what the disease caused by your vitamin D. And vitamin E, its chemical one is tocopherol. It's a tocopherol, highly commercial selling vitamin because of its antioxidant property. Its antioxidant property is making this one to selling at higher cost. Every cosmetic is going to have vitamin E. I think E capsules, it is very highly selling vitamin, and deficiency causes infertility. It's going to cause infertility, sterile. And vitamin K is anti-hemorrhagic factor. Anti-hemorrhagic factor we are going to call, and this is going to be phylloquinone. Chemical is phylloquinone. And deficiency causes blood clotting will be delayed. Hemorrhagia. We are going to call this one as hemorrhagia. Hemorrhagia will be the symptom of the vitamin K deficiency. And coming to B complex, we are going to have B1, B2, B6, B9, B12. Other than this, the numbers are not specific, that's why I am not giving them. B1. So what is B1, B2, B3, all these are comes under water soluble vitamins. These water soluble vitamins are going to be excreted through urine. That's why we are always taking B complex vitamin capsules, isn't it? So this B1 is nothing but thiamine, riboflavin, pyridoxine, folic acid, cyanocobalamin, vitamin C is called as ascorbic acid. Other than this one, we are having pantothenic acid, niacin. They are having the numbering confusion. Some are saying B3, B5, niacin and pantothenic acid. Some are saying B3 is pantothenic acid, B5 is niacin. That's why I am not specifying their name, number. And now thiamine is going to cause beriberi. This is causing chelosis, the fissures at lips. This is causing convulsions. Folic acid will be retardation in growth. That is mental growth and physical growth. Very important. If you can see, all pregnant ladies are going to use folic acid capsules because the fetus has to develop their growth, a body as well as a brain. That's why folic acid is very important. Cyanocobalamin, pernicious anemia. And ascorbic acid, scurvy, bleeding gums. Bleeding gums will be the disease we are going to get it from ascorbic acid. So B1 is going to be having these chemical names, and we are going to have diseases like this. And what you are left, pantothenic acid, which is very important for the growth of our body. Coenzyme A is going to be a cofactor which is going to be present, this B3, the pantothenic acid, whereas niacin is very important cofactor for NAD, NADP, all of them are going to have nicotinamide adenine phosphate. That is nothing but this vitamin, that B5, the niacin only. Niacin is going to cause the disease called pellagra. Pellagra is going to give in 3Ds like dermatitis, diarrhea, dementia. 3D we are going to call those symptoms. Anyway, all these things we are going to learn in your biology very well. Just the chemical names I am having the importance, that's why I have given all chemical names. I think you can note it down and you can able to remember them so easily. So this is about your vitamins. So don't think that these vitamins and enzymes are taken light, because we are going to have the carbohydrates and nucleic acids and protein. That amino acids are important for us, the chemistry concern. So these things anyway you are learning very detailed in your bio. So the nucleic acids we are going to discuss in detail. That is the topic which we left. That is going to be taken tomorrow. I hope everyone understand. So go through these videos and you can ask me the doubts what you are having in the interactions session. Thank you.